part 3 of the Star Destroyer build. I'm cleaning up my parts. I got my engines cleaned up and primered again, and I'm working on the rear engine compartment. I put these side pieces on, so I just wanted to show that because the parts are, now I can't see any top and bottom with this part. It looks symmetrical to me. I don't see any difference in the top and the bottom. So it's not marked anywhere as far as what's the top and what's the bottom. So I'm assuming, and there's nothing in the directions that specify, so I'm assuming it's symmetrical. So these parts have an arrow pointing up, so you know which one goes on the port, which one goes on the starboard. But it's on the inside, so when you put the tab on, when you put this piece on, that arrow is covered up. So make sure you label it. So I put like huge arrows so I don't miss which side is up. I'm not sure if it's really going to make a difference because it may only fit one way when I put it in the ship. So I'm not really sure, but I just wanted to make sure that I know that this is the top and this is the bottom. Also, it will matter for the holes, I think, when you drill your holes through the bulkhead. They may not line up exact if you have it reversed. So those pieces are on, and I am working on the detail in here, which is really good. There's a lot of detail on this model. I mean, for a big model, there's a ton of really small detail. But he can't cast the pipes that go in here that aren't necessarily attached. So there's a bunch of different pipes that I'm looking at that go from the surface to the side of the engines, and there's not that many of them. So that's the level of detail that I am going to go with this, where I want to see those little pipes in there. So I'm waiting for this to actually dry, and I'm going to seat my 4 small engines and then work on some piping and put some small piping in there and stuff, trying to replicate what I'm seeing on the filming model, and to get that kind of, if someone looks close at it, you know, they're going to see, wow, all these little pipes, and then they're going to see pipes that are sticking out and pipes that are going different places. It just looks really cool. And it's true to the model that they made for the movie. So that's what I'm kind of doing right now. I'm just trying to figure out what size styrene pipes I want to use and how I'm going to hook them up and stuff like that. So that's what I'm thinking about, and I'm going to start working on. One other thing I want to show you about the structure, because I ran into some issue with that. So in the first video, I showed this big structure that I made for the internal support. If you do intend to light this, so I did drill the holes for the wire to go through, so I lined up the engine piece against this, and I traced out where the holes needed to go. So there's one here, and I have to cut a piece out of here to fit one of the 4 engines, the wire, and one here. And also the center engine happens to line up with this pole inside. So you have to have somewhere for the wire to go. So don't forget to drill a hole in this pipe so you can snake the wire out of it, or the wire's not going to have anywhere to go to light the middle engine. Unless you can move it to the side, that's up to you. I just wanted to make sure I'm covered, so when I put that piece on, I don't have to worry about the wire getting stuck and having to reroute it. While I'm giving some thought to what I want to do with the lighting and the painting and everything else, I got to start on the side panels, drilling some holes for Fiber-Optic, which is tedious, but the way I do it, and it's pretty simple. I'm just going to show this real quick because I know I've showed it in other videos and I don't want to bore anybody. This is a little drill master that I got at Harbor Freight for like $10. It's hooked up to a variable volt power supply. So it runs on DC power, and if you just use it out of the box, it's probably 12 volts, which spins really fast. I bought a little chuck adapter so it'll hold a really small drill bit. This little drill bit is 0.55 millimeters. And I buy these on, I think I got these on Amazon. You can find them online, cheap ones. Buy a bunch if you're going to do this, because you'll probably break a bunch of them. So 0.55 millimeters for 0.50 fiber optic is what I drill. So the hole comes out pretty much perfect to fit the fiber. If I'm using smaller fiber, I'll use a 0.3 drill bit, which is very easy to break. I've used it on resin, and it works just as well. So I'm running this at about 8 volts, and it's running just slow enough where it'll go through the resin, but it won't be too fast where you don't have any control. So before I drill the hole, what I'll do is, especially if I'm doing a line of lights that need to be straight, I'll use a punch just to get an indentation in the resin so I can go along with 3 or 4 in a row, and they're going to be straight. They're not always straight. In fact, a lot of these aren't perfectly straight either, which is really hard to do. But they're good enough. Your eye will trick, and you will see a straight line of lights pretty much most of the time, unless you look really close. Alright, so I'll show you. Even I was worried because this resin is thick. This is probably at least 3/4 of an inch, so I had to stretch the drill bit to the very end of this just to get through, and it barely makes it through the longest section of resin. So what I'll do is I'll drill one. I'll show you. Let's see. So I went all the way through, came out the other side. You get a nice clean hole with this, and you know, it's pretty effortless. So that's what I'm working on, and I'm going to do a little bit at a time on these so I don't drive myself crazy. So as you can see, I'm doing a lot of fiber optic work, which is pretty extensive on this model. There's going to be a lot of lights. I guess if you are lighting it, there is an option to get clear parts. I didn't even know that there was an option when I bought the kit, but I wouldn't have got them anyway, because I don't really understand how the whole thing would work. So normally these sections are either buildings that are stacked or all of the detail is built in. On this version, the detail parts are left out and they're separate. So you have two choices. You can put the detail part, which this one would go, you know what, I picked the wrong one up. I should rehearse before I do this stuff, you know? Be a little more professional about it. So obviously this panel, you can drill the holes first and then put it on, or you can put it on and then drill the holes. I cut this part out so I could drill the holes and run the fiber before I install the part. It's just personal preference. I just don't want to put this on first and then be dealing with this huge part, drilling the holes and running the fiber. It's much easier just to do it on this and then cut the back out and run the fiber that way. If you use clear parts, I'm assuming that, because he does tell you to cut these parts out if you're going to install the clear parts, but how do you mask all those little windows? I don't get it. So if you light up the entire part, you're going to have to light block the entire thing and then somehow, you know, scratch the paint away for the little holes. I don't know. It just seems like a lot more work to me than running the fiber, but could be wrong. Haven't had a lot of success with clear parts. They tend to be more of a pain in the neck than they're worth. So these parts go in. I'm going to actually remove this, and I'm going to remove this whole section here. You can see I started with my Dremel cutoff wheel, but my Dremel ran out of power, so I had to recharge it. So I cut out this section here. So this section here is cleared out because this whole side section fits on like this, sort of. So that's what I'm doing. I am running fiber for the foreseeable future until I get all of the buildings done and a lot of the other parts, the side panels I'm doing here, and all the other work. I'll probably do all the fiber at once and then you know, work on the assembly after that. So there's the jig in action. It actually works really well, and it's just the right size. So you can see how the pieces all line up. I had to do some more sanding on the bottom of each one because there was some excess resin on the sides and stuff, and I still have a little cleanup work to do on the sides, and I still have to put these pieces on. I figured I'd dry fit this first and then hot glue some pieces on here so I can hold this thing perfectly steady. These are just dry fitted together with tape. I was dry fitting the buildings on here to see how they're going to sit, and what I'm thinking of doing is building the entire top section versus putting the top and bottom together first and then putting the buildings on after that. I might put the buildings on and have this whole top piece finished, and then in theory put the two halves together. We'll see how that works out. Well, I'm making some progress on the hull and the buildings. As you can see, they're fitting nicely on the upper hull. This is a nice method of putting these buildings together. I like how he has the separate parts. The buildings, I'll go into the buildings in a bit. Let me show the whole piece. Okay, so the entire whole piece is, of course, it's 4 sections. The jig helps you align them, but when you put the support, so I'm lining up the support on this, and there's no support for the middle, so this is going to fit on like this. There's no support in the center section, so there's a support here and a support here. This piece is not going to cut it. This is just a little support piece. Even if you went all the way across, it wouldn't line up all. So this is where all the 4 pieces converge, right here, and there's nothing to support that. So you can just put the panels on here, but when you go to line them up, there's nothing behind them. So I had to put in some braces that I had made. They're just 3D printed, but they're really strong. And you can use metal or whatever you want to do. But the angle of this, from what I can gather from my geometry, is and a protractor is about 24 degrees. So I made the center section, and that's epoxy that you see there. So all 4 pieces are epoxy to this panel here, and then the side pieces are supported by these 2 parts. And the thickness of these pieces isn't uniform, so I had to shim this rear piece because this was thinner than this piece. So you want them to line up on the outside. So I couldn't just press down and have them line up on the inside because then the top would be off. So I had to line it up on with the top so the seam is as even as possible. I think it turned out pretty good. It's actually, it looks nice and straight. It took a lot of work to get all the panels to line up right, and with a minimal seam in here. So you can see the seam. I filled it in with putty right now, and I'm going to address that a couple different ways. What I'm probably going to do is maybe put some strip styrene here and there, and rescribe the panel lines. And there's a piece that goes over here and over here, which partially covers the seam. And there's a center section that goes on here that will cover this. So some of it will be covered, some of it won't. And I'll have to fix that. But I really wanted to make sure that these pieces were nice and straight, and that they were all secured together nice and tight. So I'll show you the bottom piece. The bottom piece isn't put together yet. So all four pieces are face down, and I had marked on this where the supports are. Again, there's no supports in the middle. This is the little bay. So this works a little differently because there's no convergence on all four panels because of the bay, so that these pieces are going to line up here. So I need to have some way to support all of this here. So I made this, which again is heavy plastic. It's very strong, it's not going to bend. It's thick. It's like ABS plastic. So that's going to actually secure all four panels. It's going to make sure that they're all straight. And I've made this one for the front because there's no support there either. So that's going to support the near the nose, of the ship. It's going to support these two to make sure they're nice and tight. As far as the buildings go, I've never had these buildings, work out perfectly on any model Star Destroyer, except maybe if there's one out of the box, like a mass-produced kit. They're always a little bit of a problem. These are actually in pretty good shape, though. I like the way that the sides fit on. All these other pieces all fit on nicely. So, I mean, of course, there's some areas where I have to fill in some little gaps here and there. But the fit looks pretty good so far, and all my fiber has to be lit up, and I'm still thinking about how I'm going to do that. Let me show you what I'm doing for the engine lighting. So I tried a couple of different things with the engine lighting, and what I came up with was, for the small engines, I used a 5mm diffused LED, and it was a little big for the hole, so I made a little insert, which is actually clear. So I printed it with a clear filament, and the reason I did that was that will light up. So when you power on the LED, I didn't want the engine lighting to be smaller than the actual hole. So it would be like a 6 or 7mm bulb, which they don't really make. So what the 5mm LED will do when it's lit is it will light up that little bracket that goes around the light. So it will fill in the area, then you won't see it. So it looks really good. It looks like an actual bulb is filling in that whole spot. So I'm pretty happy with that. For the big ones, they were a little more difficult to try and figure out. So I had a hole here it's actually 18. So I only had a 10mm LED bulb, which wouldn't look right inside there. So I come up with another one that's clear, and it has some detail on it. And the bulb that I used, now you could use a standard 10mm LED, but I don't really like those. They're not very bright, and they shine right in your eyes. So this is actually a little LED bulb that's made for cars. It's made for like dome lights and stuff in cars. The cool thing is when you look at it head on, the LEDs face this way and this way. They face opposite sides, so the light doesn't shine in your face. So what that effect gives you is it actually spreads the light out versus just directing it towards you, if that makes sense. So that's what I ended up with, and you can see it's like the whole circle is lit up. So when you put it inside the engine, it lights up. Now, depending on how deep I put that bulb in, I can move it around, and you see you get a different effect. So I can even move it further out, so it lights the whole cone up. So there it is, as the light is kind of pushed, the bulb is kind of pushed forward, so the whole engine's lit up. Let me try and cut down the exposure on the camera and see if I can get it to look a little better. Okay, that's the exposure way down. You could see the little bulb in there in the center, but it kind of blends in with that little filler piece, which looks like this. So this is a clear filament. This is the other one that goes around the 5mm LED.
Take evasive action!